Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Throwback Thursday. So, between 3.5 and 3.2 billion years ago, during the Paleo-Archean era of the Archean Eon, the Earth didn't look much like it does today. The atmosphere lacked oxygen, as did the oceans, which had just formed along with the crust beginning to form. And the first living things, cyanobacteria, were slowly creating free oxygen. And in the midst of all of this, the Barberton Greenstone Belt was also being formed. The belt is found in South Africa east of Pretoria. It is a sequence of mafic to ultramafic lava and metasedimentary rocks, which are metamorphic rocks that still contain sedimentary structures, that were deposited during the Archean Eon. They are the oldest igneous rocks on Earth. The area went through two tectonic episodes of terrain accretion. That is, two periods of material being added to the tectonic plate at a subduction zone. So imagine it's similar to pushing sand in a sandbox to form a wall around your castle, or just, you know how sometimes you just, as a kid, would just push it to one side because you could? Some of it would go underneath, but a lot of it just kind of got piled up along the side there, and that's your accretion. This process helped to build new continents throughout geologic time. It is hypothesized that the greenstone belts formed from a passive margin oceanic crust becoming part of a subduction undercut margin. And then, about 3.1 billion years ago, a granite batholith was intruded into the belt and partially metamorphosed into gneiss. So we got two things going on here. So why is it called a greenstone belt? Well, if you recall from earlier lessons, specifically why is magma formed and what is it made of, which was one of my Monday Musings episodes, mafic and ultramafic rocks are primarily made of olivine, which is a green mineral. One of the main types of ultramafic rock found here are komatiites, named for the Komati River that flows through the area. Komatiites are a mantle-derived volcanic rock with an extremely high magnesium content and very low silicon, potassium, and aluminum content. Komatiites are rare because almost all of them formed during the Archean, when it is thought that the mantle was starting to cool. During this time period, the Earth had a much higher heat production, simply due to all the residual primordial heat of planetary accretion. In fact, eruption temperatures were thought to be up to 1600 degrees Celsius, or 2912 degrees Fahrenheit. And the lava would have flowed with a viscosity close to water. And this photograph shows here that modern basalts, on the left, typically erupt as a yellow hot lava with black crusts, but Archean komatiites would have been 400 degrees Celsius hotter and would have erupted as a white hot lava with red crusts, which would have been both cool to see, but not cool to feel at all. Komatiites are composed of forsterite, which is a magnesium-rich olivine, calcic and chromium pyroxenes, anorthite, which is a calcium feldspar, and chromite. Komatiites also take on spinifex texture, meaning that the crystals look a lot like spinifex grass, long and blade-like. And for some context, here is that spinifex grass, which, funny enough, isn't actually an African grass, it's an Australian one. But hey, they've got komatiites too. Well, thanks for coming to today's lesson, and make sure you tune in tomorrow to learn more about Paticatitan. Fossilize later.